Welcome to our lesson on Introduction to Sets and Vocabulary. So this is a new outcome on set theory, and we'll kind of get introduced to sets, what they are, a lot of language and vocabulary that we'll be using carrying forward into our probability outcomes. So before we get going too far, we're just going to basically run through several definitions and what they mean. So a set, what a set is that it is a collection of objects that are related to one another in some way. We use curly brackets to represent a set. So these little curly brackets here go around the set, and we usually denote a set with a capital letter. So for example, the set of positive integers less than 10 would be p is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Sets can be numerical, sets can be words, colors, they can be, it's just anything that is a bunch of things related to one another. Each of the items within a set is called an element. So the number 4 is an element in the set of P. A subset is a set whose elements all belong to another set. So for example, the set of even integers could be a subset of the positive integers, right? So if we listed all the positive integers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then we take out the even numbers, 2, 4, 6, 8, 10. The even integers are a subset of the positive. So this notation here means subset. Okay, so that's an important one. The universal set or the sample space, okay, we'll talk about that a lot when we get into probability, is the set of all elements under consideration for a particular scenario. So the universal set depends on the scenario we're talking about. For example, the universal set when rolling a 6-sided die, we represent the universal set with the capital letter U, would be 1, 2, 3, 4, 5, 6. Okay, the complement of a set, the complement is all elements that do not belong to a set. If we examine the sets P and E from above, so the positive integers from 1 to 10, and then the even ones, which would be 2, 4, 6, 8, the elements that are the complement of E, so we write that as E with a little kind of apostrophe at the top, would be 1, 3, 5, 7, and 9, because those are not even numbers. The empty set is the set with no elements in it. That's represented with 0 with a line through it. If we have disjoint sets, these are 2 or more sets with no elements in common. For example, the set of evens and the set of odds would be considered disjoint. We represent the number of elements in a set, so how many things are in a set, using the notation n of p. So the number in p would be 9 if we look at our example from up above. It's important to note that sets can be infinite or finite. So infinite continues on forever. Finite has a beginning and an end. An infinite set would be the set of whole numbers. This carries on forever, which we could represent like that. We use those little ellipses or little dot, dot, dot at the end to represent that it continues on. And you could actually have it going on both the front end and the back end. And a finite set has only a certain number. So example, the even numbers between 4 and 10 is 4, 6, 8, 10. We'll be doing lots of work with Venn diagrams. So these are ways of representing. It's a kind of just a different way of representing. You can use set notation or a Venn diagram if you're more of picture people. So U is the universal set. So we basically always have a Venn diagram. We put a box around the outside. That's representing the universal set. And then within that, we place our other sets. So I've got the set A, and you can see that the set B is within the set A. So we can see here that A is a subset of the universal set. B is a subset of A because it's inside A. B and A are both subsets of the universal set. And then out here we have the complement of A. So all things that are in the universal set but are not in A would be outside of there. And we'll be looking at that quite a bit in the next couple of lessons. Let's look now at some examples where we're just going to get comfortable with using set notation and drawing some Venn diagrams. Okay, so A says to list the set of multiples of 5. We're going to use F from 1 to 100 using set notation. So basically for A, I just say capital F for 5. curly brackets, and then I'm going to list the multiples of 5 from 1 to 100. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. Okay, so that's quite a big set. Then we're going to list the multiples of 10. We're going to represent that with capital T. So we're just putting down the multiples of 10 between 0 and 100. Okay, and then that was B. C says to list any subsets. So as you can see, the numbers here, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, are all in the multiples of 5. So then I can say that T is a subset of F. The multiples of 10 are a subset of the multiples of 5. We also could talk about, because if the universal set is all of those numbers from 1 to 100, we could say that T is a subset of the universal set, and F is also a subset of the universal set. Okay. D says represent using a Venn diagram. So the Venn diagram, we have the box representing the universal set, which would be all numbers from 1 to 100. And in there, we have the multiples of 5, which would be a pretty big circle, right? So this will be F. And then within that, we have the multiples of 10, which is T. And then generally, we kind of write all of those digits inside of there. 40, 50, 60, 70, 80, 90, 100. Okay, and then in the F circle, we would write all of those things that are multiples of 5. Now we've written 5, but 10 is already in there. We don't need to write it again because it's inside of the T circle. So we need to write basically all of the numbers, 65, 75, 85, and 95, because all the rest of them are in the other circle. And then outside in the universal set, out here, would be all of the other things that are not multiples of 5. So instead of listing them all, I'm just going to say F prime, because they would be all the digits 1, 2, 3, 4, 6, 7, 8, 9, 11, 13, 12, 13, 14. It would take a long time to write them all in there. Okay? Okay, we're going to take a look at another example here. It says to draw a Venn diagram to represent the sets. The universal set, U, which is the natural numbers from 1 to 40 inclusive, the multiples of 8, the multiples of 4, the multiples of 17. Okay, so I am a picture person, but before I can draw the Venn diagram, I need to kind of write out what are in these sets. So the multiples of 8 would be the numbers 8, 16, 24, 32, and 40. The multiples of 4 would be 4, 8, 12, 16, 20, 24, 28, 32. These are our 4 times tables essentially. 36 and 40. And the multiples of 17 are just 17 and 34. Okay, so now I can draw a Venn diagram. So my Venn diagram contains basically, so if I'm talking about are there any disjoint sets? So S is disjoint because 17 and 34 are not in the other. So I could write this little set S here that just contains 17 and 34. And then I've got, you can see that this is a subset because all of these numbers, like 8 is here, 16, 24, 32, and 40. So E is a subset of F. So I'm going to have my multiples of 4, and then my multiples of 8 will be inside of there. So those numbers will be, I have to write teeny here, 8, 16, 24, 32, and 40. And the other ones that are not listed yet would be out here. So 4, 8 is already in there. 12, 16 is inside. 20, 24 is inside. 28, 32 is inside. And 36 and 40 is outside. And then out here in the universal set would be all numbers not listed yet. So that will be 1, 2, 3, not 4, 5, 6, 7, not 8, 9, 10, 11, not 12, 13, 14, 15, not 16, not 17 because it's an S, 18, 19, not 20, 21, 22, 23, not 24, 25, not a space, I'm going to go up here, 26, 27, not 28, 29, 30, 31, not 32, 33, not 34, 35, but not 36, 37, 38, and 39. Okay, so we've got our Venn diagram. Then it says to list the disjoint sets if there are any. So the ones that are disjoint, meaning they have no elements in common. So E and S are disjoint. So are F and S. There's nothing in common there. And then are these true or false? So is E a subset of F? Is E inside of S? Yes, that is true. Is F a subset of E? Does that mean is F inside of E? No, that's false. There's a typo here. Is S a subset of E? Nope, that's false. Is F prime, so that's the complement of F, the odd numbers from 1 to 40? Okay. This is also false because outside of F, I have lots of even numbers. I've got 34, 2, 6, so that's false. In this example, the set of natural numbers from 41 to 50 is the empty set. That would be true because there are no numbers here that are between 41 and 50, so that's the empty set. Okay. All right, one last example here. So this is a Venn diagram without numbers, but just you can see that we can do one like that. It says to describe the sets C, S, W, and H and what they might represent. So if we look at our Venn diagram over here, you can see that in S I have shirt, shorts, and sandals. H is cap and glasses, W is coat, insulated boots, and a toque, and then I have the jacket on the outside here. So what might C, S, W, and H represent? So C, I think that's probably just representing clothing, right? It's all different kinds of clothing in there. S, when I look at that, I think that is summer clothes. I think that W is probably winter clothes. And I think that H is probably things you wear on your head, right? So a cap and sunglasses, those are things you wear on your head maybe. So B says, where would Kaylee put running shoes? Okay, so where would running shoes go? Are they summer, winter, or outside of that? Well, I would say running shoes are summer wear, but they don't go on your head. So running shoes would go like in here, right? So in C, but not in H. And then C says, is S prime the complement of S? Okay, so when I say S, this right here, S prime means complement of S. Is that equal to W? So are the things not in S equal to W? No, because the jacket is out. Right? D says to list the disjoint sets if there are any. Well, S and W are disjoint, right? There's no elements in common there. H and W are disjoint, no elements in common there. E says to categorize the items another way. So could you, if I asked you to draw a different kind of Venn diagram or categorize them the other way? So I said, well, you could do like footwear. So footwear would be sandals, and boots. Then you could do headwear. Headwear would be cap, sunglasses, toque, and then things that you wear just on your body could be your shirt, shorts, jacket, coat, right? So, I mean, that's not the only answer to that for sure, but that's just another way that we could categorize those if we wanted to. Okay, so the purpose of this lesson was just to get you kind of familiar with Venn diagrams and the vocabulary. So go ahead and practice now.